Hello and welcome to the channel. I'm Will, and in today's video we're going to be looking at the second generation of Pentium CPU. Now you're probably already aware that there was a big jump from 486 to Pentium, but were you also aware that the first generation of Pentium CPU was not particularly well received? It was a bit of a heat hog. In fact, it dissipated about 16 watts of power, which doesn't sound like much by today's standards, but back then it had people worried. If you didn't have a fan that kept running, then the CPU would stop. The other problem is that the CPU was so complex internally that Intel actually had trouble manufacturing enough of them. And for this reason, they were rare and expensive. So a lot of people made the decision to skip the first generation entirely and just go for the second. This was probably a good idea. They were dissipating only about 11 watts of power, roughly, and so they were a lot cooler, but they also came in higher speeds. So they were just a better CPU all around. So we're going to compare the second generation Pentium with the 486 today, and I think you're going to be really surprised about how much of a difference it actually made. Also in today's video, we take a look at SuperEGA in a high resolution mode using an RGB to HDMI adapter. Well, we have a little bit of a treat today. Instead of running our second generation Intel Pentium on a Socket 7 board, as would be common today, we're going to use an original Socket 5. You see, it has an Intel FX chipset, and this is actually what you needed back in the day in March 1994 when the second generation CPUs were released. The earlier boards, the Socket 4, were for first generation only and didn't support the later chips. And here's the little beastie itself. This is an Intel Pentium at 100 MHz, and it was released along with the 90 MHz version, and a little bit later the 75, and then Intel released a whole slew of different speeds all the way up to 200 MHz. Now, of course, these CPUs would also run on later boards as well, for example, the Socket 7. So in today's video, we're going to do a comparison between the Socket 5 board that we have here and a later Socket 7 board, like for like. Now, I couldn't find a motherboard manual for this, and that's a little bit interesting. So this is presumably the model number here, up in the top of the board, PBA 6326 blah blah blah. It could be a Packard Bell number, but I'm really not sure at all. I don't find anything much online about this particular board. But there doesn't seem to be very much set up on this board anyway, just one bank of switches, and these are labelled here and here on the board. The first setting is the ISA bus speed, and it can either be a quarter or a third of the front side bus. And the second setting is a little bit more intriguing. It says V2 and V1, perhaps the second and first generation of Pentium. The final setting is BF, and I'm just going to guess it's something like base frequency, so that's a half and 2/3. So we'll definitely have to try that one out and see what happens. But the slightly odd thing is switches 7 and 8 list 75 and 90, which are presumably CPU speeds. Where the 100 MHz frequency is, I couldn't tell you. And at the moment, it's a little bit hard to tell on camera, but switch 7 is off and switch 8 is on. And this isn't one of the settings that's listed on the board. So I'm just going to go with my gut here and say that's probably the 100 MHz setting. Well, let's see if it works at all. It's always a worry when setting up a YouTube video. Maybe I've just wasted a few hours and the thing's just dead. And it seems like it might be going to go. Keyboard detected. Has it hung? No, I think a CMOS battery failed. Yeah, that we can fix. Memory size decreased. I'd expect that. And floppy drive, yeah, so it's going. So this is a second generation Pentium 100 on an Intel chipset Socket 5 motherboard. Great! The BIOS configuration seems really primitive. There are just main, advanced, and security tabs. And under advanced, you have advanced chipset configuration, but there's almost nothing here. And you can't even get to the bottom options, they're just automatic. Under peripheral configuration, there's just the usual stuff as well. So I'm going to set up the floppy. I'll just disable that because I'm going to use a zip drive, which is just a little bit more convenient for me. It does seem to have detected the hard drive. This is a Connor CP30254, and there's a little bit of discrepancy about the formatted capacity of this. It's 203 megabytes here. The drive has 212 written on it, and if you look it up online, it says 252, but anyway, I'm sure this is right, so That's basically all we need to do here, I think. I'm just going to save the changes and boot it up. Now before I run any benchmarks, I want to check the cache performance. So I'm using Ray Van Tassel's cache check program here. And of course cache is just some super fast memory that is inside the CPU itself and also on the main board. And there's a couple of different ways you can have it on the main board. You could have cache on a stick, known as a coast module, which is just a stick that you plug into the board. And you could also have just chips either soldered to the board or plugged into sockets. And in my case, I just have chips soldered to the board. Now it says there's a Pentium clocked at 100 megahertz, so that's correct. And then what it does is it accesses different sized blocks of main memory over and over again. So if they're very small blocks, then all of that data will fit inside the fastest cache that's available, which is usually inside the CPU. And so you'll get one timing for that. Looks like it goes all the way up to blocks of 8 kilobytes there. And if the data is a little bit too large for that, then it'll get stored in an intermediate cache, which is usually on the main board. And so there's a different set of timings for that. And then finally, you just get the main memory speed. So this is when the block is too large to fit in the cache, and it has to access it always from main memory. And here are the final results, and nothing really stands out here over, say, a 486 system or a 5x86 system. You've got an L1 cache of just 8 kilobytes, which would be pretty normal. This is the cache inside the CPU, of course. The mainboard cache, the L2 cache, is just 256 kilobytes, and this would be a totally standard figure, even for a Socket 3 system with, say, 486 on it. And all of the scores here are not that much faster than you would have on any of those Socket 3 systems. And this is not a really huge surprise, since there wasn't a big change in memory technology between the 486 era and the Pentium era. The first thing I want to get is a Quake benchmark, and we've done a lot of these on the channel before, but mainly with Socket 3 systems, which are pre-Pentium, so 486, 5x86 and so on. With a really good board, you can expect a 486 running at 100 megahertz, just like this Pentium, to give about 11 frames a second, say with an Intel DX4100 chip. But the best score we've got on Socket 3 is with an overclocked AMD 5x86 running at 160 megahertz, and there we got 17 frames a second. Now I think it'd be amazing if this Pentium running at 100 megahertz could beat that at 160, but we'll see. So let's take a look at the score, and 23.9 frames per second, my goodness. So yeah, this really shows why people really wanted this CPU back in the day. The floating point performance in this really dominates, and that really matters in something like Quake. It really pushed the market forward. And that's probably not even an impressive Quake score for a Pentium. Anyway, the next thing I want to try is the PC Player benchmark, and this has a version that runs at 640x480 resolution. And I've never seen this run well on a Socket 3 system, so let's check it out here. And yeah, that's actually pretty smooth. It's a little bit jerky in places, so a Pentium 233MMX might be better, but what an improvement over a 486. Now, this does require a video card with Visa BIOS extensions. So if you've got a 486 board that's just limited to ISA slots and old video cards, you might not be able to run this without extra software. For example, I tried to run it with a Singlabs ET4000AX earlier and it just refused to run. But here we're getting 12.4 frames per second. Nice. So in order to see how smooth the machine is, I've loaded MechWarrior 2, Ghost Bear's Legacy. Now this is a game from 1995, so a little bit later than the Pentium CPU that we're using, but in theory this actually ran on a 486, so I think this is a good game to check the speed of this CPU. There's some pretty awesome VGA graphics at the start here, so let's try it out. This is the game, and it's a little bit of a disk hog. It's about 55 megabytes on disk, but like MechWarrior 1, there's really quite a few different missions. I've actually skipped over the first mission, which is just where you prove your worthiness. I think you're just in a turret rather than a mech at that point, and then you finally get onto the main game. Now, this is really smooth. If I move around here, you can see that this is running really well on a Pentium 100. I don't know whether it would be any good on a 486. It seems a little bit complex for a machine of that era, but technically it's supposed to run on that. Now the only real problem I have with this game is it's a little bit hard to distinguish what's the enemy and what's not. So I think these little bots here are the enemy, and the other problem is that you really have to fire a lot of times before they blow up. So there's no instant gratification, so to speak. Now here, for example, it seems like the one on the left should be the enemy according to the radar in the upper left, but the small bot is on the right, so I don't know which one I'm supposed to be shooting at here at this point. If I go around near this Mac, it just ignores me. It seems to be shooting at something else, so I don't think that it's the enemy. And indeed, it seems to imply that the enemy is behind me now, which is just not the case. So I think there's a little bit of confusion there, and probably I'm just misunderstanding what's going on. I'm pretty sure this is actually the enemy here. So anyway, if you get a little bit in trouble, for example surrounded by Macs, and believe me that will happen, then what you can do is abort the mission, and there's a really cool sequence when you do that, so let me show you that. Basically it will eject at the top of the Mac and the whole world will spin around, and it looks really amazing. So what about overclocking? Well, last night I had a fiddle with the switch settings, and I think that switch 6, the BF, is actually base frequency. So when I change that, the CPU speeds up. Now it won't actually start up at that frequency, it's too high, but if I drop the speed down from the 100 that we had it set to 90 with switches 7 and 8, then I get an overall speed of 120 megahertz. Now I couldn't get all the way through a Quake benchmark with that, but if I put enough heatsink paste on the CPU, then I can keep it just cool enough to get all the way through. So I recorded this last night, some segments which I'll do a voiceover to now, and we'll check out what happened. The first thing I did is a check with cache check just to make sure everything's working correctly, and it does report 120 megahertz, which is great. And if you look at the cache timings, you can see they're all a little bit lower than they were before. For example, the L1 cache is down to 7 microseconds per kilobyte. And then I ran the PC player benchmark, and this is up from 12.4 to 12.9 frames per second. Not a huge difference actually, and this is because we've slowed down the front side bus speed, but we've sped up the CPU speed, so they kind of almost balance each other out. It's just a little bit of an improvement over what we had before. Anyway, let's take a look at what the Quake benchmark gives us. And as you can see, we get a score now of 25 frames per second. Pretty impressive. Well, we've seen what an impressive improvement the Pentium is over the 486, even running at the same frequency of 100 megahertz. But I'm interested to know about the motherboard situation. Obviously, Socket 5 motherboards are the earliest boards that support the second generation chips, but later boards such as Socket 7 will as well. So I'm interested in taking our 100 megahertz Pentium chip and putting that into a later Socket 7 board and seeing whether it makes a difference in the performance. The motherboard I'm going to use is the one from this machine here, which we've seen on the channel before. This has a Socket 7 motherboard, and the reason I chose this one is because the mainboard is actually just PCI. There's no AGP, so we're going to be able to do a like-for-like comparison with the Socket 5 board. I decided to take the board out so we can get a closer look at it, and I believe this is the PC Chips M529 if you want to look it up. It's based on the Opti Viper chipset, which sounds really cool. And as you can see, it comes with cache on a stick. Oh, sorry, that's just a successful YouTuber's AdSense revenue. This is the cache on a stick, the Coast module, which is where the L2 cache is. And of course, there's also L1 cache inside the CPU itself. But let's not screw around, let's just find out how much faster it is. Well, that's a little bit disappointing. This is PC Player and we're only getting 7.9 frames per second instead of the usual 12.4 that we had on the Socket 5 board. So I suspect something's not quite right here. Well, that is remarkable. There were a few problems. The frontside bus was set to 50 instead of 66, and that sped things up quite a bit. And also the memory timings in the BIOS were set quite badly. They're a little bit touchy, but I did manage to get some better performance out of it. But as you can see, I'm still only getting 9.9 frames per second here. So there's something very odd with this board. Its performance really just sucks, frankly. We had 12.4 frames per second before on the Socket 5 board, so I have no idea what's actually going wrong here. And yeah, look, 21.1 frames per second in Quake, also pretty lousy. Who would have thought that a Socket 7 board would be much slower than a Socket 5, especially one with an Intel chipset? Real turn up for the books. Well, let me know in the comments if you think there's something I've overlooked. I went through all of the cache settings and memory settings and yeah, anything else that looked like it was relevant. And this board just performs like a dog. Very strange indeed. Anyway, I want to move on now to the next topic for today, and this is going back to a video that I made some time ago on the channel about SuperEGA. And one of the things I wasn't able to do back at that time was to show you SuperEGA in full resolution. Of course, I don't have a multi-sync EGA monitor, and so that's just not going to be possible. But there is another way around it. I've got hold of something called an RGB to HDMI converter, and this will allow us to at least see the output of the SuperEGA card on an HDMI LCD display. This is the RGB to HDMI style converter I got my hands on. You might wonder why some of it's taped over. This is hobby channel rules where I live. Unless you're a business, you can't promote or even show brands of currently available products. Now, some people have said, why don't you just start a Patreon account? But of course, YouTube is not really profitable enough in the tech area to get an income from this, so it'd have to be a side hustle. And unfortunately, because of various rules related to my current job, that's actually not a possibility. Now, coincidentally, I am planning to move country in about a year. Maybe this will change, but for now, we've got these silly bits of tape to worry about. And you've probably also noticed that if you put links in the comments below, even sometimes to Wikipedia, they'll just be automatically deleted by YouTube, which is bizarre. Anyway, this thing works pretty straightforward way. It has a 9-pin connector, which you can plug in an ordinary 9-pin CGA or EGA cable from your card, and that just goes in there. There's also a power connector, which is just a USB power cable, and an HDMI output for your monitor. Now, in my case, I have DVI-D input to my monitor, so I'll have a subsequent adapter for that as well, but we'll see that this setup is adequate for what we want to do today. I actually bought this for another reason entirely, so do your research into your brands and figure out which one is applicable for your particular application. This is the card we're going to be taking a look at, and as you can see, it's based on a Genoa chipset and a smart EGA BIOS, whatever that is. And on the right hand side you can see it says SuperEGA model 4850 revision B, and it's the high res model. Now I think this is just a Genoa board and that has model 4850, but I think the card itself is this one here from the Radio Times in Dutch. If you look at the photograph on the left, it's a really terrible photograph, and there's just enough information there that matches up with my card to probably identify this as being the one that I have. And if you look in the list of resolutions on the right, the first two are Plantronics modes, and we took a look at those in the previous video, and these really exist on this card. Then there's a bunch of monochrome modes, there's some additional text modes, and at the bottom you have a bunch of additional graphics modes, and the 640 by 400, the 640 by 480, there's also 800 by 600 and a few other random modes as well. So this thing really should go up to 800 by 600, and that's what I want to try out here. Now, given that we've got the high-res model, it might even go higher than this. I'm not entirely sure about that. But I'm going to use the Fractint program to test this because it actually supports some of the Genoa modes. Of course, at this point we need to switch over to the RGB to HDMI adapter. And when we select the mode, I have to do quite a bit of fiddling, which I'll show you just in a moment. And eventually it will start to display an image. And this is the 640/480 mode. At the moment it's just drawing in blocks of 4x4 pixels or something like that. It just does a very quick pass and then goes in and fills in the detail as it goes. That's just how Fractint works. But we're actually getting a picture on this monitor for one of the higher resolution EGA modes. Now, there's one issue that I've encountered with this RGB to HDMI adapter, and it's not really surprising. This adapter was not designed to work with this Genoa card. I've gone in and tried to tune the settings so that it will actually work here. But basically what happens if I go back into the normal display without the main menu being displayed from the adapter itself, it loses the picture information. So here I'll restart the machine. And you can see the image is still there, but unfortunately it's just flashing. It's only when I display the on-screen menu that I get the image stable on the screen. So this is a little bit of a strange hiccup that I encountered, but just for demonstrating this particular mode, this is absolutely fine. Of course, this card works great for the applications I actually bought it for. This was just a bonus on top, really, to be able to see the output from this Genoa card. And there's the final result in full resolution, and of course, as you can see, it's really just basically the same as what you would get on a 320 by 200 display, just at high resolution. And this really just shows you that actually colour is probably more important than resolution. I wasn't able to get the 800 by 600 mode working quite as well, but let me show you what I came up with. As you can see, there is a picture here, and it shows that the card is outputting an 800 by 600 mode, but the adapter isn't able to find a mode that it recognizes, so it just keeps changing the size of the image until it's very, very small and repeated over and over again. And this is really the best I'm able to do in the 800 by 600 mode without additional information, such as the clock frequency of the card, for example, or some of the other parameters that I need. So I didn't get very far with this. Going back to the 640-480 mode, let me show you the settings that I put into the adapter itself in the geometry menu to get this mode to work. So obviously I set the height and width to 640 and 480, and then you have to tell it what the full size of the screen is. That 640 by 480 is only the active area where the pixels are displayed. It doesn't include the border. So you have a line length here, and you have lines per frame. If you don't know that information, you might know the clock frequency of the card itself. But unfortunately, on my card, it's not labelled, and it uses some multi-frequency oscillator anyway. Now, I'm no expert in setting this up, but it seemed to me that I had to pick settings here for the max height and width that were bigger than the settings above. The manual is really geared around other kinds of displays, and so just following the instructions exactly as they are written didn't really give me the result I was looking for. So I'm not exactly sure what I was doing here, but anyway, I got it to work eventually. The other thing you need to get right for EGA is the sync type. So to signal to the monitor that it needs a special mode, it changes the polarity of the horizontal and vertical sync pulses, and there are two options, plus and minus for each, so there's a total of 4 sync types. And also you can fiddle around with the video type. There's progressive, interlaced, and I think there's another one for teletext as well. So in all, it takes quite a bit of time to set up a mode if there's not one programmed in already for your particular machine. And it can be some hours of work, but eventually I was able to get it to go here. Of course, I'm using a custom profile here, but what saved me in the end is that this adapter has a whole load of different machines programmed into it already, everything under the sun. And all I needed to do was to scroll through to some of the PC modes, and I found this ET3000AX, which is some kind of VGA card. Some of these come with a 9-pin VGA output. And then I went down to the sub profile here and changed it to basically VGA, and this started to look a little bit similar to what I wanted. And so from there I managed to tune it in using the settings that I showed you to get something that was stable without the flickering that you see here and the sort of grey look that it has. Now obviously these RGB to HDMI adapter solutions that are available out there are really targeted at the very popular 8-bit machines and also the CGA and EGA modes of the PC. and perhaps as a side effect, also the 640 by 480 mode of some VGA cards, at least the ones that have a 9-pin VGA output. So it's not too surprising that I wasn't easily able to get an 800 by 600 SuperEGA resolution working. Once SuperEGA came around, of course cards had a standard VGA output and you could just plug an LCD monitor straight into those. You didn't need a solution like RGB to HDMI. If you have any ideas about how you might get those higher resolution modes working, put a comment below. I did try some of the other higher resolution modes, but really had pretty much the same amount of success as I did with the 800-600. And of course, there's also that Senglabs ET3000AX mode. I think we have to try that out on the channel at some point as well. Anyway, that's it for this week. Thanks very much for watching, and don't forget to like and subscribe if you haven't already, and we'll see you in a later video. Bye.